Hi guys, in this video we're going to start learning about volume. We're going to spend a couple of days on it because today we're going to learn just how to do volume of prisms and cylinders and some types of composite figures. So let's just review what a prism is real quickly. So we talked about it already when we did surface area, but remember that prisms have two bases that are the same shape, same size, they're parallel to each other, okay? So then prisms are named by their bases. So, for example, if the base of it were a rectangle, we would call it a rectangular prism. This one is laying on its side, so the base is a pentagon, and so you would call that one a pentagonal prism, okay? If it's a square base, it depends on whether all the faces are the same square, then it would be called a cube usually. But just keep in mind that the bases are the same shape and size, and they're parallel to each other. And then a cylinder is basically the same thing as a prism, but it gets its own special name when it has a circle as its base, since a circle is not considered a polygon. So we're kind of lumping all these things together, prisms and cylinders, because you calculate their volume in the same way. So first of all, let's remind ourselves what volume really is. So it's a measure of how many little unit cubes, so imagine one of these little cubes here, does it take to sort of fill a figure up. So what you're going to do in a prism is you're going to calculate how many unit cubes it takes to cover the base first, which will be like calculating the area of the base. So in this case, we would do 5 times 4 to find that. So can you imagine that it would take 20 cubes to cover just the bottom layer? Then there'd be 3 layers of 20, so then you multiply by the height. So for example, this particular rectangular prism would have a volume of 60 cubic centimeters. We measure it in cubic units now because one little cube has a length, a width, and a height. It's 3-dimensional, so the units are going to be cubic units now. So in general, that's what you're going to do. You're going to find the area of the base. So the way this formula is written, this B stands for area of the base. And then you're going to multiply it by the height. Now, keep in mind the area of the base can be a different shape, though. Like the one we just looked at was a rectangle, right? So if it's a rectangular prism, you just do length times width to find the area of the base, then multiply it by the height. The shape of the base can be different though, so just keep that in mind, okay? So we can write the formula like this, or your formula sheet that I gave you at the beginning of this chapter, or you can get this off of Polaris. This is how they express it. So these prisms are all kind of laying on their sides, imagine, okay? So it's the same thing. They're telling you find the area of the base. So they're looking at this as the base in each situation. So it could be a triangular base, it could be a rectangular base, it could be a circular base, but now no matter what, you're going to find the area of that base, because again, like I showed you on this last slide, that's like one layer of unit cubes, but then there's this many layers, so you have to multiply it by the length or the height we commonly express, okay? So we could write in parentheses here that sometimes we just call that the height. So again, as we move forward here, make sure you have this formula sheet out in front of you. So find the volume of the rectangular prism below. So I'm going to write the formula like this: area of the base times the height. So again, this part's going to change based on the shape of the figure. So the shape of the base in this case is a rectangle. So how would we find its area? So you're going to do the length of the base times the width of it. So 4 times 2. Let me actually... So I wanted to actually write it like this real quick because I just want to remind you, this part is going to change every time. In this case, because it's a rectangle, we're going to take 2 times 4 or 4 times 2, doesn't matter the order. So the length times the width times the height in this case would be 5. So you go ahead and tell me what you're going to get as the answer for that one. So 4 times 2 is 8, times 5 is 40. Again, look at your units. The lengths are all measured in plain centimeters. The volume is now going to be measured in 3-dimensional units. It's unit cubes. How many little unit cubes does it take to fill this figure up is what it's a measure of. Okay, you guys go ahead and try another rectangular prism one on your own. Okay, again, here's the general formula, but the area of the base changes depending on what the shape of the base is. The shape of the base in this situation. Now, really, we could look at what I just outlined as the base, or we could look at this as the base. Maybe it's laying on its side. Okay, let's try it that way. Let's use 5 times 3 as the base this time. And then that's, again, like one layer of unit cubes. You got to multiply. You're filling it up when it's volume by the height of 13. So 5 times 3 is 15, and 15 times 13, you should have gotten 195 cubic centimeters. Okay, this next one, what does it look like? This is another prism. But the shape of it, the shape of the base this time is a triangle, okay? So what we're going to do this time is we have to, again, it's like placing one layer of unit cubes across the bottom, then filling it up. So you multiply by the height. So let's write our formula. Volume equals area of the base times the height or the length, whatever you want to call it. So again, this part here, I'm just going to rewrite. This is going to change. This time the base is a triangle. What is the formula for area of a triangle? So we're going to do 1/2 times base times height there. Now, you know, I'm actually going to change this to be L for the length of the base, like it has written on your formula sheet this time, because I don't want you to get confused between I don't want you to have 2 different H's in the formula. I don't want that to confuse you. Okay, so why don't you see if you can just do this part for me first. Find the area of the triangular base. So when you're doing this, guys, you should focus just on the front of this figure. The base would be this 3, and the height, remember, in a triangle has to be perpendicular to the base. That's why it's drawn in here. So it's actually 3 as well. So 1/2 times 3 times 3 is going to give us so far 4.5. And then we have to multiply that by the height, which is also 3. So go ahead and take that area of the base times the height and see what you get as your final answer. So the area of the base, 4.5 times the height, 3, is going to give us 13.5 cubic yards would be our unit this time. Again, volume is always going to be measured in cubic units. Okay, we have another triangular prism. So focus on just the base first. Doesn't matter if you look at the bottom of it or the top of it, because the bases are the same shape, right? So our formula requires us to find the area of that base and then multiply it by the height or the length of the prism, okay? So again, let's just talk about this part first. The area of this base or the top is a triangle, so we're going to have to do 1/2 times base times height. So what do you think the base and height are of this triangle? So here's the thing, guys. We, at this moment in time, we know this side is 4. We know from looking at the bottom, we can tell that this is 5 because that would be the same length. But here's the thing. The base and height in a triangle, they have to be perpendicular, remember. So that means this and this are the base and height. So we know that we could use 4 as the base, but we don't know the height at this moment. How can I find this right here? So did you notice this is a right triangle here? So I can use the Pythagorean theorem. So go ahead and see if you remember how to set up the Pythagorean theorem and find this missing side length here. So a squared plus b squared equals c squared. Remember to look for your hypotenuse first. That 5 is our hypotenuse. By the way, guys, did you remember 2 is the height, like the third dimension of the figure? It has nothing to do with this triangle on top that we're looking at right now. So anyway, the legs are 4 and x. So then you're going to square all of your numbers to get 16 and 25. You're going to take away 16 from both sides. And so you should have gotten that x squared is 9. Don't forget to take this square root. So x is 3. Some of you might have known that without even doing the math. You might remember that 3, 4, 5 is what we call a Pythagorean triple. Okay, so anyway, now we can fill in this number. We know the height is going to be 3. So let's go ahead and find, this is part of this is just the area of the base. We're later going to have to multiply it by the height of the figure, but go ahead and find just the area of the base first. So 1/2 times 4 is 2, and 2 times 3 is 6. And now we have to multiply it by the area of the base times the height, which is that 2. So what will the final answer be? So 6 times 2, area of the base times the height, is going to give us 12. Cubic centimeters is going to be our unit. Okay, a cylinder is the same type of thing as a prism, because again, we just have to find the area of one base. Since the bases are the same shape and size, we find the area of one base, and then we have to put 12 layers, in this case, of unit cubes to fill up the whole thing. Okay, so think about the formula for any prism or cylinder. You take the area of the base times the length or height. Okay, again, your formula sheet uses L for length. I prefer to use an H, but it's up to you. So the area of the base, what will we fill in for that this time? So if it's a circular base, area of a circle is what we're looking for, which is pi r squared. You can look back and find that in the area portion of your sheet if you forgot how to do it, okay? So this is how we will find the volume of a cylinder. So let's go ahead and fill everything in here. So we're going to have pi times radius. It goes from the center to the circle, so it's straight up given to us. It's 4. And then the height of the figure, again, is 12. So go ahead, plug this in your calculator, see what you get. Now, I personally would simplify a little bit and do the 4 squared first, which is 16. And then I would go ahead and take 16 times 12 first. It's always nice to multiply by pi at the last minute because it's going to make things ugly. So 16 times 12 is going to give you 192. And then the pi comes, I can write it after because multiplication is commutative. Now I can go to my calculator. By the way, sometimes you might be asked just to leave your answer like this. We call that writing it in terms of pi. But it does say in the direction we want to give it to the nearest tenth, which means we actually want a decimal. So we want to go to our calculator and do 192 times pi. And when we do that, 192 times pi, again, use the caret key. Don't use 3.14, not as accurate. 603.2 tenths is 1 decimal, and we have to round up because the next digit is an 8. So 603.2 approximately, and our units were centimeters, so volume will be cubic centimeters. Okay, something I want you to think about real quickly. Imagine taking a stack of coins and calculating the volume. If the same stack of coins were not stacked as nicely, how do you think the volumes would compare? So the amount of matter here, the number of coins is still the same, so the volumes are going to be the same. So there's something called Cavaliere's principle. You don't need to know the name of this, okay? But it tells us that the volumes would be the same. It helps to think about it layer by layer. Again, you have the same number of coins, so it's going to be the same volume. So then this is just saying if you have a right prism, which means one that's perpendicular to the ground, versus one that's slanted at a different angle, we call that an oblique prism. If they have the same base area and the same height. This one, you just have to make sure you would never measure it like this, okay? You're going to have to measure it perpendicular to the base, so it would have to be drawn in outside. But if this number is the same as this, if they have the same height and the same base area, their volumes will be the same, okay? So go ahead and try to find the volume of this, just like we did on the other prism. It doesn't matter that it's oblique. You're still going to take the area of the base and multiply it by the height. So again, let's write this out a little bit more detailed. Area of the base in this case, because it's a circle, means that we're going to be doing pi times radius squared. Then we'll have to multiply it by the height. So pi times the radius is going to be half of 18, okay? Don't forget, you have to have the radius in this problem, in these area problems. The diameter is what we're given, so we have to take half of it. So we're going to be plugging in 9 in place of the radius, and then the height is this perpendicular length out here. How tall is the cylinder? Again, I like to do some simplifying first. 9 squared, because please excuse my dear Aunt Sally, right, is 81. And then multiplication is commutative. I always do this part first. 81 times 14 is going to give us 1,134. Then I like to wait till the end to multiply pi, because again, sometimes it might say write your answer in terms of pi, meaning leave it like this, or it might say give the exact value. Once we multiply by pi, we're going to be giving a rounded version, okay? But this one wants that because it says give it to the nearest hundredth. So 1,134 times pi, you should have gotten about 3,562.57, okay? Again, you have to make sure you're following your rounding rules. The next digit is a 6. 5 or above, we got to give this a shove. So writing the wrong thing here. It's about, we should use the approximate symbol here, 3,562.57. Let's go back for our units. These lengths were all in inches. So, again, area of the base would be square inches. By the time we fill it up, those are cubic inches we're talking about now, a third dimension. So make sure you have cubic units. Okay, last type of problem we're going to look at for today is what we call a composite figure. We did these with area, 2 dimensions, okay? So it's going to be the same idea when you're looking at 3 dimensions. A composite figure is composed of multiple shapes, okay? So with this particular one, what kind of figure would we break this up into? What kind of figures would we break this up into? So you're going to break it up into, I would say, 3 different rectangular prisms. Okay, so you know what? Let me actually color code it. Okay, so I kind of broke it into sections. Now, you're going to have to kind of use your imagination, okay? Let's actually start with the 3rd rectangular prism, like the highest step of this, if you kind of look at it like steps. I'm going to start with 3 first because you can kind of see the whole thing of that one. So I think it will help you understand the others better then. So again, we're going to be doing, for any prism that we have to find the volume of, area of the base times the height. Now this is a rectangular prism, right? Like, let's look at this as the base of it. So let me ask you this. Area of the base, let's fill this in, means we have to do length times width, and then we'll multiply by how long or how high the prism is. So if I want to find, let's outline this in red for a minute. Let's focus on this as the base. How long would this be? Okay, what you're going to have to do is, trying to pick the color that's going to stand out the most. You're going to have to take the length of this. Did you notice these little congruence markings here? So that means there's 3 of them spanning this. So we're going to split this 900 or divide it into 3 equal parts. So this little part right here would be 300 then. 900 divided by 3 is 300. Okay, how long do you think this is going to be right here? So it's, look at over to the side again. Okay, we have that this has the same congruence marking as this did here. So this length right here is also 300. So think about the height of this whole thing then. 300 plus 300 more plus 300 more, or 300 times 3. This is going to be 900. So this length is the same as this length. They're both 900, okay? So then the area of the front of this right here is going to be 300, the length times the width here, 900. And then you got to look at the third dimension. Again, think of that like one layer of unit cubes. You got to multiply by how high or how long it is, which we know is 1200. So go ahead and figure out what that will give us for the volume of this first section here. So it's a big number. You should have gotten 324 million. And then this, remember, is cubic millimeters, okay? So let's take a look at this middle section here that I highlighted in blue. It's another rectangular prism, so we're going to have to do area of the base again times the height. So let's look at the front of this. What should we use, do you think, for the length and the width of this? So the length, again, was, look for that little marking here. We said one of these little marked sections are 300. Remember when we found that earlier? And then the height would be, what do you think? So again, it's 1, 2 of these little sections combined. So 300 plus 300, or 600. And then, okay, you really got to use your imagination here. That's how we find the area of the base, okay? 300 times 600. So now think about, that's 1 unit layer, the front of it. How long will this be all the way to the back? Because we can only see this part, but it's blocked by this. You have to imagine that it's going to go all the way back. So it's going to be the same as this. They're all going to have the same height, okay? That 1200 is how long they are. So what's going to be the volume of this section? So 300 times 600 times 1200, you should have gotten 216 million cubic millimeters for this one. Okay, and then section 1 up in the front, you see if you can do this one on your own this time. So we have area of the base again, which is length times width, and then times the height. Area of the base this time, the front of this is just 300 by 300. And then, like I told you earlier, again, you have to use your imagination because you can't see this whole step, right? Again, these kind of look like steps. Picture walking up the steps in real life. The length of this step is going to be all the way across, like the top one in the front and middle one. It's going to be 1200. So you're doing 300 times 300 times 1200. And that's going to give you 108 million cubic millimeters. Okay, so remember the volume of the whole figure will be the sum of all 3 of these volumes now. So what will the final answer be? So when you add all of these numbers together, 324 million plus 216 million plus 108 million, you should get 648 million cubic millimeters.